All right, lesson 7 is all about refraction of light, getting into more like lenses and refraction, also called Snell's law is another name for the equation we're going to have. Okay, first thing you need to know is index of refraction is how much a material bends light. Okay, so if you ever notice, when you look at something through a thick pane of glass, it looks like it's in a different place because the glass bends the light. Same thing with water. If you look at bends light. Okay. Look at a glass of water and then the straw looks like it's like bent off the side, because the water also bends the light. Okay. And for a vacuum, which we're talking no air, N is actually about, it's still basically 1.0 for air. It might be 1.0001 or something, but if we round it to the nearest tenth, it's still 1.0. Something like water is going to have 1.33. Okay, so this is another way to look at it. If I said, hey, what's the speed of light in water? You actually take the speed of light in air or vacuum, 3.0 times 10 to the 8th, if you remember, meters per second, and you divide that by 1.33. Okay, so light goes slower in water than it does in air. So if I would divide that out, just divide the 3, divide by 1.33, it's 2.25 now, or 2.26 times 10 to the 8th meters per second. All right, so another thing that N tells you is how the factor by which it slows down the light. Okay, because the reason it bends is because it's getting slowed down. All right, so it goes slower in water, and water will bend the light. The higher this number is, the more it will bend the light. So like diamond, I don't know off the top of my head, but diamond has a index refraction of maybe like 2.5, this N. All right, so these are index of refraction. So diamond bends a lot, so that's why diamonds tend to sparkle. They're bending that light all over the place. Okay, here's the math you're gonna have to do. Here's Snell's law, the equation for refraction. N1 sine theta 1 equals N2 sine theta 2. And your situations will look like this. You have like a pane of glass or something. You'll have, like, say this is like, or we'll say water. So this is going to be N1, which would be like your air. The light's coming in, hitting. Remember when we measure the angle, we measure it from this normal line. It's actually going to bend. Draw that normal line straight through. It's actually going to wind up bending inwards, you'll find. So it's going to actually wind up going like this. This is theta 2. And then this material down here is the N2. So basically, you got some material, some angle entering in. You got another material down here, and the angle will be different because the light's going to bend once it's going through. Okay, so let's say it's air, 1.0, entering water, which is 1.33. Let's say it comes in, a beam of light, hits at, let's say it says 40 degrees. So make sure that when you do that, for this equation to work out, you got to put it from the normal line. It doesn't go here, which it makes, more common sense that you put it here, but for the equation here, the angle has to go here. So let's see how it works out, and then we'll draw the other part of this. Okay, so just plug everything in. 1.0 sine of 40 equals 1.33 sine theta 2. We're trying to figure out theta 2, right? We're trying to figure out what angle it enters here at. Okay, so probably should put down here theta 2 equals question mark. Okay, look up, do sine 40 on your calculator. Hopefully, find a calculator that can do sine, cosine, tan. You can find one on the internet pretty easily. Make sure it's in degree mode. I'm getting 0.6428 times 1, so 0.6428. Divide by 1.33, right? This is a multiply here. Divide each side by 1.33. 0.6428 divided by 1.33. I'm getting about 0.48 equals sine of theta 2. Inverse sine, oops, not squared, 2. So inverse sine, if you remember, is how you solve this. So I got to do an inverse sine on 0.48. So again, you're going to have to find it on your calculator, how to do an inverse sine. So hopefully I can find it here, 0.48. Inverse, I think I just hit second on my calculator, sine -1. So I'm getting 28.7 degrees. All right, so you do need to find that inverse sine. So what that means, when this light comes in here, it's bending more inwards, right? And this angle is 28.7 degrees. All right, it bends in. If you're going from water to air, it actually would wind up bending out. Okay, it would actually bend away from the normal line, but when you're going in here, it's going to bend in. So basically, just use that equation. If it asks you to solve for a different variable, you guys should be able to handle that. It might say, hey, it might give you theta 1, theta 2, and n1, and you got to solve for n2. Okay, but I feel like you guys can handle that. Basically, just use that equation for all these problems.